Now we're going to go to the last question of our show. This one is a question that comes from Diets of Filet. We might not finish it based on the amount of time that we have left. So let's just share a couple of ideas based on how far we can go with it. It says here the first two terms of an arithmetic series A are given there, and a geometric series of infinite or to infinity B are the same. Okay, the first two terms of an arithmetic series A and a geometric series to infinity B are the same. Okay, so now first question says write down in terms of A, a big combination of words that trouble people. When we say in terms of A, it means our final answer is going to contain A inside. So we're not really looking for a numerical solution. We want an answer that's going to have A inside. Okay, so now we say we want you to find the third term of the geometric series B in terms of A. So let's put them here. The arithmetic one, okay? Don't use black. Let's use a different color that you guys can see. The arithmetic pattern, A is obviously arithmetic, okay? And what do we know about an arithmetic pattern? It has a common difference. This one, we're going to need to figure out what the common difference is. The one B that you have there, this one is apparently geometric, okay? What does a geometric pattern have? It has a common ratio. Okay, so just know the difference between the two. 3.1.1 is asking us for the third term. So you're looking for term 3, okay, of the series B. So this is basically where we are. 3.1.1 is here. We want term 3 of these guys, okay? What was the term 1? Term 1 is -2, okay, plus term 2 is A, plus we want to know what is the third term going to be. You can use a formula for the general term Tn in order to figure out what term 3 is going to be, or you can just use the common ratio. The common ratio between these two is always term 2 divided by term 1. So if I divide this guy by that guy, I'm going to get the common ratio when I do term 2 divided by term 1. So the ratio is going to be A divided by -2. Now, if you've got the common ratio and you're trying to move forward to find subsequent terms, you just multiply term 1 times the common ratio will give you term 2. And then term 2, if I multiply it also with A over -2, which is my common ratio, it should give me what term 3 is going to be. To move forward, you multiply. So term 1 times R gives you term 2. Term 2 times R is supposed to give you term 3. So which means term 3 has to be A squared over -2. No thinking involved. You could have found it using the formula Tn from the formula sheet if you wanted. All right. Now, the next question, 3.1.2, says the third term of the arithmetic series A. So we're looking for third term again for the arithmetic guys. Okay, cool. The arithmetic guys also begin with -2. They follow with A. So we want to know what will come next. All right? Let's use the same idea of what exactly is going on in a pattern. Now, we need to find a common difference, which you find by saying term 2 minus term 1. Remember, T2 minus term 1 will give you the common difference D. Okay, so A minus -2 will give you a D value of A plus 2. What does that mean if this is the common difference? What it means, to move from term 1 to term 2, you add the A plus 2. So -2 plus A plus 2 will give you A. Now, on that A, if you add an A plus 2 again, you just keep adding the difference to move forward, you're going to end up with 2A plus 2 as your term 3. You could have still used the formula in this one to figure out what the solution is going to be for term 3. So I basically found my 2 term 3s from both the first and the second question. Okay. Now the examiner continues and says the sum of the first 3 terms of the arithmetic series A is the same as the third term of the geometric series B. Write down an equation and determine the value of A. That's a lot of English. Okay. Now, because we got a lot of English and we're not so good in English, we're going to convert this to mathematics and see what exactly is being asked here. When people talk about the sum, they're talking about adding terms. So when they add the first 3 terms of the series A, okay, mathematically that would look like this. The sum of the first 3 terms of the arithmetic pattern, okay, is the same. Is the same, looks like that in mathematical format, equals to the third term equals to term 3, the third term of the geometric series B. So that's basically what we're dealing with. If you add the 3 terms in series A, you're just going to get exactly term 3 in B. Okay. So you don't need a formula, beautiful people, to work out sums all the time. You only use a formula if you're working out sums that are too big. Now, these ones, I'm going to add them manually, which means negative 2 plus a plus 2a plus 2. This is the sum of the first three terms from the arithmetic pattern, is equals to term 3, which we found as a squared over negative 2. So that's my equation that relates the two, which I can then solve a on. So let's find what the answer is going to be here. I'm getting 3a, negative 2 and 2, they cancel each other. I'm sitting with a squared over negative 2. Then I do simple multiplication by negative 2 on both sides. You get negative 6a equals to a squared. You just put a 0 here. You've got a squared plus 6a, okay? And then you just factorize by taking out a common factor. 0 comes out as a into a plus 6. Using the 0 factor law, it means a is going to be 0 or a is going to be negative 6. So I'm getting two values here. One of them is insane. They can't both be correct. Why? If you think about it, a can't be 0, because if a is 0, it means all the terms of the geometric pattern are going to be 0. Term 2 in series B will be 0. Term 3 will be 0 over 2, which is also 0. So you actually wouldn't have a pattern if a was 0. You'll just have negative 2 and a long list of zeros. So that means this is not going to be acceptable. The only a value you're taking is negative 6. Some stuff. Right. Now, in closing, let's check the last question. If a is negative 6. Now, when I see things like this after answering a question, it just puts a smile on my face. It means I got the answer correctly, because why would the examiner suddenly give me an unknown a value? That is just random. It's not random. They know what the answer is going to be. Okay. So if a is negative 6, determine if the geometric series converges. Okay, does the series converge if a is going to be negative 6? Let's go back and rewrite the geometric pattern that they told us about, okay? The geometric pattern that they told us about starts with a, okay? This is very important for us to keep in mind, okay? Right. It starts with a value of negative 2, and then it follows with a, and then it follows with a squared over negative 2. If you replace a with 6, you're going to get negative 2. This is going to be minus 6. That's going to be negative 6 squared, which is 36 over negative 2. All right? Because you're going to put negative 6 there where a is. If you square that, it becomes a 36 that is positive. And when you have 36 and you divide it by 2, you're going to get an answer of negative 18. Okay? So these are the first three terms of that particular geometric pattern. Right. Now, once I've got that, they're asking if this thing is going to converge or not. What do you know about convergence? For a series to converge, the common ratio must be between negative 1 and 1. It can't be more than 1. It can't be less than negative 1. It must be 0 point something or negative 0 point something. So that's just what they're testing. So let's see what our R is going to be in this case. According to what I'm looking at here, R will be negative 6 over negative 2. My R comes out as a positive 3. Now, this does not lie in the range of interest. Remember, for convergence, for a pattern to converge, your ratio, R, has to be between negative 1 and positive 1, excluding even both negative 1 and positive 1. So if it's here, then it means your pattern will converge or your series will converge. But if it's here, then it means it will not converge. Okay, very important. This is a region for convergence, very important. And then this one is a region for no convergence. This is where the series will just simply diverge. So please keep that in mind. We want it to be negative between negative 1 and 1. But we just got an R value. If a is negative 6, our R value comes out as 3. Because it's coming out as 3, 3 is somewhere this side, okay? That means it will not converge. It only converges if it's between negative 1 and 1, okay? So your conclusion is based on what the examiner was asking. The examiner asked something pretty basic. They're saying to you, if a is negative 6, will this series converge or not? I was trying to just find the question and see. Let's go back and read the actual question. If a is negative 6, determine if the geometric series converge or not. So I'm going to close by saying will not converge. Why? Because your R is not between negative 1 and 1. Absolutely awesome stuff. I hope this has actually helped you to understand what you needed to do. I thoroughly enjoyed myself on today's program. Thank you very much for joining us. A big shout out goes out to Liberty. A special shout out to our production team for putting up all this. And a big shout out to you for joining us after this. It's accounting. Until we meet again next time. Bye-bye.